And we are back. So, I think I did a little bit of an intro before. Yes, we have with us David, 0xdf, one of the best people to work with in Hack the Box, eternal knowledge in everything from sysadmin to IT to hacking to blue teaming to anything. And the most amazing part is that he actually has also a life. I think this will be my question: how you can manage know all these things, be so calm. I cannot, and also being always so helpful with anyone. Actually, that is very nice because David is in the committee that they release boxes and not, and they give also constructive feedback. Let's give it up to an amazing hacker and co-worker. Hello, David. How are you? You are muted. We cannot hear you.
Oh, can you hear me now?
Amazing.
I've been watching the talks today, and it seems like everyone comes on muted, so I had to follow suit, right?
Yes. And how do you feel?
Doing great. How are you?
Good. I think everything is better. Also, the testing of the CTF for tomorrow is going much, much better. We are pumped up. I also brought a little tricks for the office, in order to prep for the stream. We are going also to be all of us here tomorrow in order to support the CTF. I don't know. I think it's teamwork 101.
Awesome.
So I feel blessed. Do you want to start presenting your screen so I can
sure.
add it?
Let me share that 1 second.
Yes.
Window.
To anyone that says that is good to have this face. Yes, perfect. Make sure also to watch. I will link it while David is watching. I will link also his talk about how to create successful machines of Hack the Box, this NEA that we had with him. It was amazing. And also to follow his channel. It is dope. So I'm going to add it to the stream. It is black. What is going on? If I did like that, oh, we have an issue. Let me remove it. It is a... Okay, I think we have an issue. Perfect.
For a second there.
Perfect. Okay.
Yeah, weird place. Can you hear me now?
Yes, everything is amazing.
Awesome.
Perfect.
All right, should I take over?
Yes, do you want us to be in this display or this display?
Oh, no, go back. You can go to the other one.
Perfect. Okay, so
perfect.
I'm going to give it up, and you can speak and ask all your amazing questions to David, and let's go.
Awesome. So today we're gonna go through some of the forensics challenges from last year's Cyber Apocalypse CTF, kind of a warm up of skills and things we might want to know going into this year's. So we're gonna just pick a couple of challenges and go through them. We're gonna start with oldest trick in the book. And so when you downloaded this one here, I don't have the actual form up here, but it's just a download, and the prompt basically says a data breach has been identified. The invaders have used the oldest trick in the book. Make sure you can identify what got stolen from us. So with forensics, you always want to, so what are we trying to do here? Okay, we need to figure out what's going on, and what do we have available to us? We have this oldest trick.pcap. The pings.pcap is actually something I made yesterday. I'll show you guys that in a minute. So we'll go ahead and open up oldest trick in Wireshark and take a look at it. And when you're in a CTF and you get a PCAP, there's really two kinds of challenges. One where every packet in that PCAP is important and part of the challenge, and one where they try to throw a bunch of unrelated data that you need to sort through. And both can be fine. It's hard to make a lot of realistic looking junk data, but that's also more realistic when that's there. So that's you will see that. And so right away you want to kind of try to figure out, like, am I dealing with something with where every packet's involved, or do I have just a ton of packets? And so if we scan through here real quick, we can see look at the packet numbers. Oops, of course I just sorted it. If we look at the packet numbers, there's 37,000 packets in here. It's a pretty good guess that not all of them are related. I see a bunch of different stuff going on. And so a really useful place to start when you get a PCAP is up in the statistics menu in Wireshark. So, I often will jump to endpoints or conversations, but actually looking at protocol hierarchy is a really interesting one to look at. And so we'll open that up here and see what we can get here. So this does an analysis of the packets. And so, and it really sets it up kind of like a tree. So here at the top, we have frames. So Ethernet frames, that's everything's an Ethernet frame, unless you've got some sort of weird non-typical internet-based thing. So that's fine. These Linux cooked mode capture, I'm not actually sure what that is, but we're going to kind of just skip through it. So then we have IPv6 and IPv4, and they're both at the next level. And we also have some ARP, some address resolution protocol. And so it's about half IPv6, half IPv4. And so, okay, that's useful to know. And then we have some TCP traffic here in IPv6. And interesting, this is where I started to get, a little bit intrigued. You look at this IPv4, and almost all of it, I mean, 54% out of 55% is ICMP. And so ICMP is, most commonly associated with things like pings. So that's interesting. There is a ton. There are 20,000 ping packets in here, or ICMP packets. We're going to think it's probably pings. So I'm going to go ahead and close this and come over here. We go ahead and do a filter on ICMP and see what we get. Excuse me. So if we scroll up here to the top, let's actually sort the right way. So starting at packet 1800, we've got ping, this is a ping echo request followed by ping echo reply. We see the two hosts involved are 192.168.1.7 and 1.8. And that looks to be pretty much what we're looking at going through here. Wireshark will do a lot of really nice things for us here. So if we click on a packet, again, we can come up to the very top here, and it gives us these same layers. So we have the frame, and if we look at the bottom at the actual data, we can see that that's really the whole thing. This Linux cook capture looks to be the Ethernet headers. So then we have the packet type, blah, blah, blah. Not super interesting to us at this point. So IPv4 headers, and then here's the ICMP, and we can even open that up and look and see, okay, it's an echo request that's type 8, and you can see here it's type 8, and it's also highlighting the 8 byte right here of where in the packet it says that. So we can go, let's make some little more space down here, and we can even see the different ICMP headers, and then eventually we have data here. And if you've never looked at ICMP data, I actually wanted to pull this up. I was looking at this yesterday, and I thought, what do different ping packets typically look like? And so here is my Linux machine, my Linux VM pinging Cloudflare DNS. And you can see a standard Linux ping, actually the payload, once you get here, is actually the bytes 10, 11, 12, 13, 14, 15, just counting up to 37. It's a 48 byte payload, and it counts up. And if you look at the reply, the same data comes back. Here we have 10 through 37 with some other stuff at the front. If we have a few of these going on, and you can see it's always the same. The payload's always the same. Interestingly, if you ping from a Windows box, so this 163 box is a Windows VM in my network, pinging my Linux host, it tends to send parts of the alphabet in ping packets. So you get A, B, C, all the way through W, and then it stops and goes A, B, C again. Does it matter? Is that important? No, it's worth knowing, like, oh, what does a typical ping packet look like? And so you can see here in the reply, it sends the same payload back. And so ICMP, when you ping something, you expect the same payload to come back. That's part of the test to make sure it worked. So just a quick look at some ping traffic in general. So it's kind of weird when we come over here and we see the ping payloads. Now, the request and the replies is the same, but now every ping request is different. And in fact, we can even do, we can put a filter in here and say type equals 8, so just get the requests. Hopefully, yep, here we go. And so, now we can sort of step through these and we see, oh, every payload is completely different and it's changing. There's one other thing that may have jumped out to you if you've done this for a while. These capital PK, is a very, to me, that just catches my eye, and right away I think zip file. If you're not familiar with that, if you don't have the association from doing that for years, I'm going to show you one of my favorite Wikipedia pages. I probably could have preloaded this, but oh well, we'll go for it. Wikipedia file signatures. It's the only Wikipedia page I've ever edited because I think it's fun to add to it. Let's see if that'll find it for us. My internet's running a little bit slowly here today, but when this pulls up, I can show you PK. So, oh yeah, here we go. List of file signatures. And this page, so literally, there's these things we often refer to as magic bytes or file signatures. You'll hear them called a couple of different things like that. And basically, the idea is that like these are the different file structures, and there's thousands of them. Typically have some kind of header or something that indicates what kind of file it is. And so, you know, if you know that a PK is the start of, or let's pick a different example here, and we'll do PNG. It's a big page, and we'll see if, PNG. That's PCAP-NG. So here we go. A PNG file, the image file, always starts off with 89, 50, 47, 4E, 47, etc. And what's kind of cool is that 50, 4E, 47 is the capital P, capital NG, capital G. But so anytime you see that something starting with that, you can recognize, okay, that's probably a PNG file. In fact, when you run on Linux the file command, it's checking these magic bytes against a database to say, you know, do I recognize any of these things? Now, they're not always the first byte. Sometimes they're at some offset or whatever. But, you know, in general, most files have some kind of structure here. So why do we come in here? If you see that PK in there and you go, well, that's interesting at the start of the file. What does that mean to me? PK is the start of a zip file. And so that's interesting. It's worth keeping in our heads. So we can start to form a theory here that maybe like if this is a PK as a zip and we start to see strings showing up in here as well, I wonder if, you know, there's PK again. I wonder if this is a zip file being transmitted over pings. And so if we're going to test that theory, we will, there's probably some tools we could use to pull this out, but this is where I have a love of Python and I just want to jump in and play with Python. So we'll start writing a Python script to do this. So we'll call it parse.py. So we always start off with our shebang here, user and Python 3. And so now we're going to use a library called scapy. And so we'll do from scapy.all import star. In general, that's not the best Python syntax, but that's what scapy wants you to use. So we just do it. And then the way we read the packet with scapy is we do pkts, or whatever we want to save it as. Oops, save it as equals. And then we'll do, it's rdpcap, older trick.pcap, I believe is what it's called. And I'm going to actually stop it right there. And we'll go to the bottom here, bottom screen. And what's cool, I don't actually remember how to do any of this stuff. I just always figure out how to get enough that I can then play with it. So we can now do parse.py. And we can run it and see if it has any errors. Oops, I meant to, well, let's see if it has any errors first. And it takes a second because it's loading a large PCAP. It's taking longer than I expected that to take. I killed that for a second. I'm not sure why it's getting stuck. Let's see. So packets equals read pcap older trick pcap. Does that seems? Did I get the file name right? Older trick pcap. Okay. This is the problem with the demo. You know, with the demo gods are not being friendly to me here. Let's try this again. We'll do Python 3 and parse.py. Oh, and what I wanted to say is what I like to do is add a -i here. And what that -i is going to do is it's going to drop us into an interactive shell after it runs. So it's going to run the script, which up to this point does basically nothing. It's going to, you know, read this variable. It's going to create this variable pkts, but then it exits. So it doesn't actually do anything. Nothing prints to the screen. But if I put the -i there, now I'm going to drop into a Python terminal and I can start to play with it. So I guess while it's running, I didn't expect that to take so long to run. So while it's running, I'm going to start to think about the next kinds of things I'm going to do. I really just want the ICMP packets. There's so much other stuff in there, and I just want the ICMP stuff. So I'm going to do ICMP equals, And I'm going to do a loop again to just pull out the ICMP packets. So we start off with P for P in PKTS. And what this will do right here is absolutely nothing. Well, it'll basically recreate PKTS for me. So it's going to loop over PKTS, and it's going to, for each item in packets, it's going to put the item packet P. So that's not very interesting. But then we can say, like, if, oh, okay, cool. Now we can go play with it. It's loaded here. We can look at the bottom now, which I realize is probably not on the bottom. It's covered by my head, so I'll zoom out. So if we look at the lang of packets, we got 37,000 packets here. And so this is what I was going to start showing was we can do P for, well, we can do, let's see, we can do PKTS 0 and look at the first packet. So this is a packet. There's the Ethernet. There's some IP stuff. This is a UDP packet. It looks like a DNS packet. Cool. Okay. See, I'm going to scoot my terminal over here so it's not blocking this on my face. Okay. Hopefully y'all can see that now. So that's kind of cool, but I want the ICMP packets, right? So we can do something called, let's see, we could do ICMP equals P for P in PKTS if P dot has layer ICMP. And that is going to give us the list of the ICMP packets. And so if we do len of ICMP, now we went from 37,000 packets down to 20,000 packets. So we're making progress there. In fact, we don't want all the ICMP packets, right? We want just the ones that, otherwise we're going to get duplicates because they're exactly the same going in and out. And so if you remember, we saw that the request was a type 8. So we can do something like, let's look at the first ICMP packet. Here it is. We can now say, well, let's look at that packet's just its ICMP part. So we look like that. And you can see here the type equals echo request. So that's cool. So we can actually do .type, and it will show me that it's 8. And so now we'll go back to our thing here, and we'll say, we're going to give me all the P for P in packets, only if it has the ICMP layer, and if P ICMP .type equals 8. And so if we run that again, and we'll up arrow here, now we're down to 10,000, exactly half of what we had before. So that's exactly what I expected, right? Because we expected to cut half of those out there. So let's go ahead and move this up into our script. So we'll grab we'll just copy this right here, put it up here. So now we have our script up here with that. So now what we want to do is we actually want to loop through all of these packets, and we want to pull out the part we care about, right? We want to pull out where I saw the PK. So maybe we'll go back to, well, let's see. So we'll come down here and we will look at ICMP packet 0 again. Look at the first one. And we know we want the ICMP part. And we know we want you can see here, this stuff is all called in the part called load. So we'll do .load, and that's the load. And now you can see that this PK part shows up here, and it's repeated. And it's probably easier to see in the Wireshark itself. Oops, double click. If you look down here, so like here's the PK, and it rolls for exactly one line, which is 16 bytes, and then it starts again and it repeats itself. And if we start looking through these different ones, we see that same pattern again, 16 bytes, and then it repeats itself. And so I don't think we actually want to repeat it 3 times. I think we want just that first bit. So let's come back over here, and to our load, we want to find where in here we actually get, we have this key that we want to start on PK. So I'm just going to take some guesses here and do like, what if I did 16 to 32? Actually, that nailed it. And I can just test if I did 16 to 48, I get it twice. Here comes the same thing over again. So in fact, I could do 32 to 48, and that would be just as good. So we'll come back up here, and now we'll say like, okay, well, we're going to save something called payload equals some bytes, and we're just going to start it as empty. And we'll do for P in ICMP. So we're going to loop over our packets, and for each packet, we're going to say payload plus equals. So we're going to add to that p.load. We can use 32 through 48. Doesn't matter. We can also use 16 through 32. 6 of one, half dozen the other. And that will be there, very nice. And then we can come down here and we can do something like with open out.zip write binary as f.write payload. So now we will have looped through this whole PCAP. We have pulled out from each one. We will have pulled out the associated 16-bit bytes, and we'll have write that to a file. Because that took so long to write the first time, I'm actually going to do this all in my. So I can go up here and rerun this. But for whatever reason, parsing that took a long time. So I'm just going to actually run this stuff in my Python terminal down there. And let's see, what is len of payload? We can play with it. Okay, 161,000 bytes. And let's write that to a file. And I've still got it in my script, so if I ever do want to rerun it, I can. But let's go to a new screen here, and we will do file on out.zip. And it is, in fact, a zip file. We can do unzip. I'm going to try to go a little bit faster here because I'm realizing I'm going longer than expected. Whenever I run unzip, I always start with unzip -l. In this case, we can see it's going to put everything in a FINI directory, so that's great. But it's really annoying when you've got a directory with a bunch of stuff that you've been working in, and all of a sudden you unzip some file and it just dumps 30 more files in there, and you get completely lost. So in this case, it doesn't matter. But if this had not been in a directory, I would have definitely wanted to put it in one before I unzipped. So we'll do a quick unzip, and we will go into this directory and see what we got here. So looking through this, it's clear. This is another one where we could start Googling some of these file names, and we'll quickly figure out this is a Firefox profile. Things like places.sqlite for cookies.sqlite. This is how Firefox is storing what's going on with you as you do things. So we want to parse that. My favorite tool, I've used this in a bunch of Hack the Box write-ups recently, is a tool called FirePWD. So we will do Python. I've got it in my ops directory, FirePWD. And if we run it with -h, you can see it'll show you basically we point it at a directory here with -d. So we'll do -d and we'll point it at the current directory. Let's go up a directory, and we will do -d fini, and we run it. And it's going to dump out all the saved passwords and things, which in this case actually gives us the flag. So here's the flag right here. This save password includes the cyber apocalypse flag. So there's other stuff in here that might be interesting, but that's the solution to this challenge. So given that I'm taking longer and it's going slower than I expected, I'm going to jump straight over to the next challenge I was going to look at, which was called invitation. I'm always excited when I get to look at a phishing doc challenge that I didn't write, because it means I get to solve a phishing doc. So let's see, they give us the prompt here is, last night I received an invitation, but after I accepted, some weird things were happening in my computer. I've got a invite.docx.docm, and we're going to ignore the Python script for now. So what we're going to do with this is we are going to run olevba. We could open this up. So typically, if I was doing this like in a professional setting, I would want to take this over to a isolated Windows box and take a look. Maybe you want to look at the document and what's going on. But when you can work on a Linux box, it's really nice because the odds that this Office macro is actually going to infect you is very low. So it's very safe to play here. olevba is kind of my go-to thing for looking at embedded macros. So if we run that on this, and I'm going to type it into less, because otherwise it's going to just scroll through my whole screen. It dumps out the macros just like you could get by going into the native tools. So again, looking through here, we've got the file here, and it's OpenXML. There's some macros going on here. Now it actually turns out this stuff at the top here is actually repeated. I don't quite understand why it printed it twice, but we can see here VBA macro, new macros.bas. There's a sub, which is like a function called auto-open, which is this is what's going to run when you open it, auto-open. We'll notice right away this ODSU function right here is being passed what looks like a bunch of hex strings. And we'll go down some more. We keep getting just lots of that pattern of just decoding hex strings, it looks like, until we get to the very bottom. And this really, anytime you see the shell command, like that's with VBA, you want to zoom in on, like, okay, I'm looking at the shell command. That's something is running here. And it's running the result of a lot of these, decode commands. Again, I'm assuming it decodes. And in fact, we don't need to assume for very long because right here we have that function. And what is it doing? Well, it takes in a string and it is looping over that string, stepping the length of that string, stepping 2 at a time. And it is then creating, basically getting the midpoint of wherever I am and getting 2 bytes. So it's going to get 2 characters at a time. It's going to put ampersand h in front of it. So you're going to have ampersand h character, which in VBA is hex. It's going to get the value of that. So it's going to convert that hex value into a number. And it's going to turn it back into a character. So we are basically hex decoding this. It is anding that with the name of the function. VBA is a crazy language. And for whatever reason, the return that you set the function name equal to something to return it. So if I have a function named hello, I can say hello equals and give it a string, and then that's the string that goes back. So effectively here, what it's doing is it's taking the function name, it starts empty, and it just keeps appending on over this loop a character at a time until it's done and it returns. Then OLE VBA also spits out all this really nice stuff that it thinks is suspicious. So it's calling out for us that there's auto open. It's calling out for us there's a shell. It's calling out for us all this kind of encoding. I'm seeing char, I'm seeing hex strings, I'm seeing a lot of hex strings, which we saw a lot of hex strings too, so that's not surprising. So what I want to do, deobfuscate this. And this is, for me, again, this is where like, whatever you're comfortable doing it in, this is where I've gotten kind of comfortable working in Vim. So what I'm going to do is actually save this to a file. And I'm going to save it to a file. I'll just call it like hex. I think that's probably what that other one is. Hex.txt, right? So we run this again, and it takes a second to run. And we now vim hex.txt. And we're going to, first thing we're going to do is we're going to spend a minute and just delete a bunch of stuff. So we don't need this first copy of here. If we had a little more time, I could go through and show you it is exactly the same. We don't need these headers. So I can get down to here, and I don't actually need these variable declarations. I can delete all that. And I can come down to the bottom and do the same thing. And I don't actually need this hex decode function because I know what it's doing now. Oops, I meant to do Shift V to select rows, and now I can go down. I don't need all this alert stuff, so I'll get rid of it as well. And there's 2 ways I can go about it. I can sort of make myself some pseudocode and just sort of try to figure out what's going on. Actually, I think I can make this without too much difficulty into a Python script. I already showed you guys I like Python, so why not work with that, right? So first of all, what we want to do is we want to do, so I'm going to do colon to go down into the Vim menu, %s for substitute, / I'm going to replace that with, let's see, we'll call it unhexlify, which is the Python thing for taking a hex string and turning it back into bytes. And we will do that with globally. And so now all of those things became unhexlifies. Now we also need to deal with, okay, well, they're appending strings with ampersand. So we want to get rid of that. So we'll do the same thing. %s, we're going to replace ampersand with plus globally. They also, in VBA, when you want to extend a line, you put underscore and then a new line. And we want to get rid of that because Python will be very confused by that. So we'll do %s this underscore back n, and we will just put a nothing there because it looks like let's put a space just to be sure, and we'll get rid of that. And now we have not that many lines. Let's go to the very bottom here. So yeah, we have 5 lines. You can see right here at the bottom of the screen. 5 lines, the 5th line is 207 long. So it looks like, we're setting a variable here, which is going to be unhexlify a bunch of this stuff. We'll go ahead and do from bin ASCII import unhexlify. I always misspell that, so it's probably still misspelled, but let's see. We'll see in a second. So now we run that, and we get down to this. So all these first 4 lines are going to run fine because they're just taking in hex strings, unhexlifying them, and building strings. This shell string is not going to work fine. Let's get rid of it. We don't need the shell part. We want to just know what it was going to do. So we'll go to the end of the line here, and that looks like it's going to work for us. We can do a print x here. So I've called this hex.txt. Let's move hex.txt to hex.py, and we'll run. There's no way this is going to work the first time, but let's give it a try. Hex.py. Oh, it did work. Beautiful. So what did it print out? Okay, it was going to pass to shell, PowerShell.exe, no exit, hidden, blah, blah, encoded command this. So that's pretty cool. So we've just like pretty quickly gone through and taken this encoded VBA, converted it to Python, and gotten what it was trying to do. I'm going to shrink down this text so we can copy this, because this looks very clearly like, ooh, I was smaller than I intended to go. This looks very clearly like some encoded commands here. Let's run this again so we can get a clean copy. And we're going to grab this. And we're going to see what it is. Let's go to a new window. We'll do echo. And I realize this is tiny, but I'll make it big in a second. And we're just going to pipe echo this, between quotes, into base 64 minus D, so we can see what it's going for. In fact, let's do that and pipe into less. And now we'll get big again. Oh, so we have an issue here. This is something you're going to be very familiar with if you deal with Windows stuff, which is that Windows likes UTF-16. And so what we're really dealing with, this looks unreadable, right? But what we're really dealing with is all these up caret followed by @ signs are just null bytes. So we can get rid of that. Let's go back to our script. Probably gonna run out of time here before I get to actually finish. But we can go to our script here real quick, and let's say print x, and we will decode UTF-16 and see if that fixes it for us. Oh, we gotta. Oh, that's not gonna. No, that's not gonna fix it because it's base 64. We can go back into here and we can base 64 in here. We could also. Yeah, we'll do that. So we will come in here and we will say from base 64 import B64 decode, and we will B64 decode X, and then we will decode that UTF-16. See if that works. So we have Python x.py. Ooh, that did not work. We will go back. Let's do this the other way. Let's go ahead and grab this string, and we'll go into CyberChef, because that seems like when you're having trouble with the command line, you can always go to CyberChef. So I don't even know how long I've been going, Sodi. If I probably am running out of time here. But I will just keep going till she tells me I should stop.
Okay, David. Yes, we are a little bit out of time. If we can wrap up a little, I don't want to interrupt the flow because I see how engaged everyone is. So,
cool. I can wrap it up pretty quickly, I think.
Thank you.
The problem with live demos is it always breaks when you're not expecting. So we're going to run it. We'll go to CyberChef real quick. We can throw this into CyberChef, and it'll decode. Well, this is assuming CyberChef ever loads for me. So what we're going to find is this has got some encoded PowerShell like we expected. And what's neat about this challenge, and what threw me the first time, is that the challenge actually, you very quickly are like, oh, there's another base 64 encoded blob. I better look at it, and you decode it, and it's very clearly a reverse shell. And you think, cool, I found the reverse shell, but then it's not clear why. There's no flag. You don't know what it's doing. So what's going on? And there's some other stuff going on around it, and that actually is setting that command to run as a scheduled task. And so it's in that scheduled task that you actually find the flag. So I guess the moral of the story and the tip I would give you guys going forward for, as you do this tomorrow and in CTFs in general, is make sure you try to, look at the different places it's going. Don't always just go to the first thing you see. Or if you do, you might run into a dead end. Don't be afraid to back up a little bit and look at different parts of the code and understand what's going on. So I don't know why CyberChef. I don't know exactly why. I don't know if it's StreamYard eating all my bandwidth or what, but this seems like a demo fail on this point. So maybe this will be a good place to turn it over to Sodi and kick it back to you all.
Thank you. Thank you very much, David. Yes, it's true. It takes a little bit of a lot of bandwidth, but it works pretty good. So thank you very much for having you here at the talks. Did you enjoy it? Everyone is excited, to be honest.
Oh, good. Yeah, you always like it better when your demos work flawlessly. But when I used to always watch like the IPSec videos, my favorite parts were when he got stuck on something, because you get to watch how he thinks through things and how he troubleshoots. Hopefully you all got some value out of that, even when I floundered a little bit.
That's very nice. Let's get some of the questions that we have. So, what is your favorite kind of forensics challenges?
Oh, I mean, for me, I love phishing documents. I think they're so fascinating. I've given a presentation on this before last year. If you want to go check that out, it's on YouTube. I just think the cat and mouse game of, attackers, it's not a technical escalation. Like, it's not the most elite thing in the world. It's just like creative thinking. And how do I get my payload into a document that someone's going to run? And I mean, again, these guys, a lot of the ones who are doing it they're the bad people out there, right? They're doing it to try to do bad things, but like, you got to like tip your hat to the creativity that they come up with. It's impressive.
And what is new in phishing documents?
You're seeing Microsoft just recently is making it so that you can't run macros out of documents that have the mark of the web, so things that you download. And so that's been I think that's going to be really effective. And so you're starting to see things like wrapping so the first thing the bad folks came up with is, what if I put a phishing doc inside an ISO file and attach that? And when you open the ISO file's got the mark of the web, but the phishing document doesn't. So then, we bypass that. Well, now they fixed it. So it's just, again, it's the cat and mouse thing of just going back and forth.
Okay. To be honest, I don't know if someone from my previous pentest team is watching, but it was one of my also most amazing things to create the phishing documents, and how you can bypass all the Wi-Fi. And like that is actually very funny. We were sending documents to each other, and we were trying to check the corporate antivirus. So we were trying, to bypass. I don't know what we had at the time back then. So yes, and we're trying, and we're sending it to people and say, open it. It's okay. They didn't know. In order to understand, of course, because if we run it in our laptops, the IT would take them for review, etc. And we wanted Windows native and like a paid infra. So we were sending it to people who's like, open it. It's okay. I want to see something. So yeah, I can understand your passion about it. It always also changes. So thank you very much, David, for your time. And I'm going to remove you now from the stream. So
sounds good. Bye, everyone.